Nearly half of carbon dioxide that is in the atmosphere is absorbed into the ocean. When that happens, it causes ocean acidification. Ocean acidification is the ongoing decrease in the pH of the Earth's ocean caused by the uptake of carbon dioxide from the atmosphere. So the added carbon dioxide in the ocean causes an increase in acidity. Acidity is then measured in pH, or what is otherwise known as potential hydrogen ions. When it is absorbed, it causes a chemical reaction to what is known with carbonic acid. From carbonic acid, it can split its hydrogen ions and then go on to form bicarbonate ions. And from this process, it can break down even further and release more hydrogen ions to form what is known as carbonate ions, which is essential to marine life.
So from carbonate ions, calcium carbonate comes to play with most marine life. Calcium carbonate minerals are the building blocks for the skeletons and shells of many marine organisms. In areas where most life now congregates in the ocean, the seawater is supersaturated with respect to calcium carbonate minerals. This means there are abundant building blocks for calcifying organisms to build their skeletons and shells. However, continued ocean acidification has caused many parts of the ocean to become undersaturated with these minerals, which is likely to affect the ability of some organisms to produce and maintain their shells. Warming ocean temperatures are contributing to coral bleaching and making them more susceptible to diseases. Nutrient and chemical pollution coming into the oceans from rivers is also making suitable coral habitat very scarce. Natural threats impacting coral reefs include predation from urchins and a variety of fishes, and also tropical storms. Coral reefs are naturally very resilient to many of these threats, but now their ability to recolonize and grow sturdy structures is being compromised by ocean acidification. Sometimes coral habitat is gradually being replaced by non-calcifying organisms like seagrass once the coral has been killed off.
Because of ocean acidification, there will be changes in the marine ecosystems that will have consequences on human society. So one consequence is seafood. So ocean acidification has the potential to affect food security, especially to oysters and mussels. And due to the decrease in oysters and mussels, the food industry will lose billions of dollars. So another consequence on human society is coastal protection. Coral reefs also protect shorelines from destructive action of storms and cyclones. So the coral reefs, since ocean acidification is causing dying coral reefs, the coral reefs can't prevent loss of life, property damage, and erosion. And the last consequence in human society is tourism. So in Australia, the Great Barrier Reef Marine Park attracts 1.9 million visits each year. But since coral reefs are dying, this tourist spot will become less popular and will lose lots of money.
Hi there. I'm here to talk about ways to reduce ocean acidification, which in turn is to reduce carbon dioxide in the atmosphere. One of the main ones that I'm actually a little weak to, is to eat less red meat. Other than simply, the production of beef and all the CO2 that produces with, packaging, killing the animals and such, and all the work equipment, the animals themselves produce a lot of CO2, which is much worse than actual carbon dioxide, because they produce methane. Other than that, we need to go towards green energy. Right now the energy we use are non-renewable: oil, coal, natural gas, which is going to run out, and other than that they are producing large amounts of CO2 into the air. So what we need to do is clean, renewable ways of energy, which are solar, which you may know in our school campus on parking lot 30, or wind. We already do implement wind, but we need to go bigger. The bigger the windmill, the more renewable energy we'll